everybody. My name is Anna, coming to you from the Michigan Science Center for another episode of Echo Live. You might notice I don't quite look like I'm at the Michigan Science Center today, and that's because, like many of you, I'm actually home for a holiday break. So thank you for those of you who are starting to tune in on the Michigan Science Center's Facebook page, YouTube channel, and even right here in Zoom. I hope that you're all enjoying a little bit of a break from school. Wanted to start out by saying congratulations for getting through this semester. I hope you're all enjoying some time at home, safely, warm, inside your houses, and spending some time with your family, your loved ones, and your pets. Now, I'm coming to you from my home, but we've got a pretty exciting plan for our show today. Now, there's really no better time of year for me to talk about the topic of today's Echo Live episode than right now. We're going to talk all about the North Pole, because the North Pole has some very interesting science behind it. Now, if you haven't done so already, go ahead. I can see some friends starting to tune in on Facebook and in Zoom. Introduce yourself in the chat. Tell me who you are, where you're watching from, and maybe what you are excited to do this holiday break while you are off from school. I know that I'm excited to spend some time at home, wrap up some gifts, and give them to my sisters and my parents. It's going to be really, really fun. So today's episode we are calling North Pole Quest. And I'm going to be quizzing you on a little bit about what you know about the North Pole. And then I'm going to tell you some of my favorite fun facts about the North Pole, things that I think are pretty interesting. So here during North Pole Quest, I figure let's kick it off with just a little bit of a trivia question. So our first trivia question for you all has to do with what sorts of animals live at the North Pole or in the North Pole. So, question, which of the following animals does not call the North Pole home? So, of these animals that you see on screen, which one of these animals does not live at the North Pole? Your options are polar bears, walrus, penguins, Arctic foxes, or unicorns. Okay, interesting question there. So take a moment, think about what you know about the North Pole already, and tell me which of these animals would you not find at the North Pole? If you were ever to go there for a visit, tell me which of these are you unlikely to see there? Because this is one of my favorite things about studying biology. Many of you know that I am a biologist. I study living things. And so when I learn anything about a new place or a new part of science, I love to talk about the living creatures and the living organisms. So this is a pretty fun fact. Ooh, okay, lots of people starting to tell me that they don't think unicorns live at the North Pole. I've certainly never seen one, but let's find out the answer. Now we've got two actually correct answers here. Many of you told me unicorn, and I put a big question mark over there, and we'll get to that one in a moment. But the other correct answer to this question is that there are no penguins at the North Pole. Now, penguins do live at one of the poles, but actually we only find penguins at the South Pole. And alternatively, we only find polar bear at the North Pole, which is why you never see videos of polar bears eating penguins. And trust me, if they lived in the same part of the world, polar bears would certainly love to have a penguin as a meal. Polar bears are known to eat any sort of small mammal that they can catch. They're extremely fast swimmers. They're great hunters. And so a polar bear would eat a penguin. However, they're not quite close enough geographically, and so there are no penguins at the North Pole. Now, what about that big question mark on unicorns? Now, it's not just because we're unsure if unicorns are real or not. Who's to say, right? Maybe a little bit more scientific exploration needs to be done about unicorns and where they might live. But there is a sort of unicorn that does call the North Pole home. Narwhals are what we call the unicorn of the sea. And narwhals are my favorite species that inhabit the North Pole, the very northernmost part of the world. We call them the unicorn of the sea because of that long tusk that comes right out of the front of their head. Now, that tusk is actually made out of a material similar to what human teeth are made out of. And so it's always growing. And that tusk can actually grow to be up to 10 feet long. That's an enormous tooth or an enormous horn, which is why way, way, way long time ago when sailors first started seeing narwhals, they thought they were some sort of mystical creature like a unicorn, giving them a pretty cool nickname. All right, let's move on. I've got another trivia question for you all. So we've talked a little bit about what sort of animals inhabit the North Pole. But how about this question here? This one has to do a little bit more with people. So my question for you all is, which country owns the North Pole? So in the very center, I've got a map of the North Pole. So the map you can see right here in the middle of the Arctic Ocean, there is this blue X. That is the North Pole on a map. Now I'm curious for you to tell me which country owns the North Pole. The options are, is it Canada? Is it Russia? Is it the US? Or is it Denmark? And Denmark is pretty far south, but Denmark owns Greenland, which is this body of land right here, which is actually pretty close geographically to the North Pole, right? So tell me, what do you think? Which of these countries owns the North Pole? Evan from Texas. Hey, Evan from Texas. Evan says Denmark owns the North Pole. Most likely because it's the closest one, right? A couple of people chiming in. A little bit of mixed reviews. A couple of people not responding because maybe we're just not sure. So let's find out the answer. The answer to this question is a bit of a trick. Actually, none of these countries own the North Pole. That's because the North Pole has no owner. The reason for this is that the North Pole is a giant sheet of ice with nothing underneath it, which is actually pretty different from the South Pole. The South Pole is a body of ice that's actually over a landmass that we call Antarctica. But the North Pole, is just one giant floating ice sheet on top of the Arctic Ocean. Since there's no land underneath it, that means that no one country can own it. But that doesn't mean people haven't tried. All of the countries that you see up here on the screen have tried at some point to claim the North Pole as their own. That's because the North Pole, even though it's a sheet of ice, actually has all sorts of natural resources near it. There's about 30% of the world's oil is located in the North Pole or near the North Pole. There's all sorts of other metals, but none of these countries can actually claim it as their own, which makes a very interesting part of science. Because all these countries actually have to share its resources and share the discoveries that take place there. Now, people don't actually permanently reside anywhere near the North Pole. People have gone to the North Pole, and several communities of Inuits have actually traveled near and around the North Pole for hundreds of years. But since this body of ice is actually constantly in a state of moving, no one permanently resides there. And it's actually pretty difficult to get to the North Pole because the North Pole, like we said, is constantly growing in the wintertime. That body of ice is freezing and it's growing, and it's shrinking in the summertime. But people have visited the North Pole. The first explorers who are credited with visiting the North Pole actually went there in 1909. This is a photo of the team who actually visited the North Pole. The two most famous explorers would be Matthew Henson and Robert Peary. They actually went there with a team of Inuit guides who helped them to get to the North Pole. And it's a little bit disputed on which was actually the first person to get there. So we'll just go ahead and credit them as a team. But we should also give credit to the most important team members that they had, which were their dogs. Robert Peary and Matthew Henson actually got to the North Pole first by dog sled. Now, I've never been dog sledding, but it seems pretty fun. And that was actually the best way to get there many, many years ago. Now, since then, people have visited the North Pole by giant ice-breaking ships, but you can only do that in the summertime. People have also visited the North Pole by airplane or helicopter, but people have also visited the North Pole by submarine, which is pretty interesting, right? Because since there's no land underneath that sheet of ice, explorers are also able to get there by submarine. And so Russia actually planted a flag on the bottom of the North Pole ice sheet. And that ice sheet is really only anywhere between 6 and 9 feet deep. So not a very thick piece of ice, although in the wintertime, it can grow up to the size of the United States wide. And then during the summer, it shrinks down to about half its size. And so if you're ever hoping to go to the North Pole, you can. There's all sorts of trips that you can book, guides that will take you to the North Pole. It's a little bit expensive, not a very easy trip, and it takes a very, very long time. But since that ice sheet is constantly growing and shrinking and growing and shrinking with the seasons, there are only certain times of the year that you're actually able to go there. Now, if you are ever thinking about going there on vacation, you should also know what the climate is going to be like. The average temperatures in the Arctic Circle or up near the North Pole can get pretty interesting. Now, would anyone like to take a guess? Just how warm do you think it gets in the North Pole in the summertime? Because the North Pole is part of the Northern Hemisphere, just like where I live here in Michigan. I'm not sure if anyone out watching is from the Southern Hemisphere, but we definitely go through seasons where at some parts of the year it's warmer and at other parts of the year it's colder. And so does the North Pole. It has seasons as well. It still has 4 seasons, although they're just not as distinct as where I live here in Michigan. So I'm curious. It is officially winter where I live here in Michigan. It's officially the start of winter as of the 21st when we had the winter solstice. And the temperature here today is pretty warm. But what do you think the average winter temperature is at the North Pole? It must be colder than Michigan, right? Because it's further north. And if we think about the reasons for the seasons, right, we know that the further towards the poles we get, the more extreme our seasons get because of the tilt of Earth on its axis as it points either towards or away from the sun. The average winter temperature, the cold time temperature in the North Pole, is actually about negative 40 degrees Fahrenheit. Ooh, that's very cold. But what you might not know is that the North Pole is actually the warmer of the 2 poles, and that the South Pole gets actually much, much colder. Wintertime in the Southern Hemisphere can actually drop down to about negative 70 degrees Fahrenheit. So way too cold, which is why no one permanently inhabits Antarctica either, down on the South Pole. All right, now let's talk about my most interesting set of facts that have to do with the North Pole. Did you know that Earth actually has 2 North Poles? Not 1, but 2 North Poles, and not 1, but 2 South Poles. The reason for that is that one of these is the geographic North Pole, which is generally what we've been talking about so far, and the other is the magnetic North Pole. The geographic North Pole is where the Earth spins on its axis, just like we talked about with our seasons. And you can see that that is located in this photo along this green line. So the geographic North Pole is where explorers were constantly trying to find back in the days of Matthew Henson and since then. People are trying to find that northernmost point on a map where the Earth actually spins on its axis. But the magnetic North Pole is the more interesting one in terms of science, because not only does Earth have 2 North Poles, a geographic and a magnetic North Pole, but that magnetic North Pole is moving. It's actually traveling from where it originated when we first discovered the magnetic North Pole, farther and farther and farther away from that original point. Now, the Earth is a giant magnet, just like any other magnet that you might see or might use. The Earth, you can see, has a North Pole and a South Pole, and surrounding the Earth is what we call the magnetosphere. The magnetosphere is basically Earth's magnetic field, and it can actually travel out into space and loop around about 70,000 kilometers out. So way, way, way far away from the Earth's surface, our magnetic field can actually travel. And we said this is actually quite similar to any other regular magnet that you might use. So I've got a bar magnet here with a north and a south pole, just like our Earth has. They have a fun experiment for us to try to talk about what that magnetosphere looks like. So I'm just going to switch my camera over here to my tray, and I'm going to take my bar magnet here that has the North Pole and the South Pole. I'm just going to slide it down underneath my sheet of paper here. Now, inside this shaker is actually something called iron filings. And iron, as you might know, if you remember back to our episodes where we talk about magnets, iron is one of those metals that is attracted to a magnet. So I'm going to take my iron filings or my iron powder here, and I'm just going to sprinkle it over the surface of the paper. Now, of course, some of those magnetic filings are going to stick to the magnet, but the others are actually going to arrange themselves in the shape of this magnetosphere. You can picture this as if this was the Earth. You can actually see that inside this magnet, there's actually a north magnet and a south magnet, and each one has its own set of poles surrounding it. You can see that, especially right here, you can see the lines that designate this magnet's magnetosphere, or its magnetic field that travels from north to south pole. Very interesting. Now, the reason I put it on top of the paper, right, is so that it doesn't stick, because I can just pick this up and shake it back into my container. But I have another fun experiment that you can try at home to talk about the Earth as a magnet. Because the last thing I'd like to show you how to do is how we can actually find the North Pole. How can we find the North Pole? There's a specific tool that we use in order to find the North Pole. I'm sure we've all used one before. It's not a magnet, but it works using a magnet. Does anyone know what I'm talking about? What kind of tool might you need to use if you were looking to find the Earth's North Pole? Now, if we said it works off of a magnet, it's also important to remember that this tool can only direct us towards the Earth's magnetic North Pole, not the geographic North Pole. But this tool is what you're all telling me is a compass. So I'm sure that you've all used a compass before or seen a compass. And thankfully, living in the modern age that we do, there are tools that you can find on your phone, or more specifically, there are apps that you can use to find a app here to help you find the direction north. So cell phones are super cool and handy, but what if you don't have one? I want to show you how you can actually build your own compass or your own tool in order to find the Earth's magnetic North Pole using just a couple very, very simple household materials. The only things you'll need for this are a bowl of water. So I have a bowl of water here. I'm just filled about halfway full. Any size, just as long as it's bigger than these other two supplies. You'll also need something that floats, like a plastic bottle cap, or you can also use a sliced up piece of a wine cork, just as long as it floats in the water, and I'll show you that in just a moment. And then you'll also need a needle. So if you're going to be doing this experiment at home, ask your adult if they have a needle that you can use, one that looks just like this for sewing, but also make sure that you're being very careful, because one of these ends is called the business end, and it's very, very pointy. So just be careful. This is a very safe experiment that you can definitely try at home. The last thing you'll need is a magnet. Any sort of magnet will work for this. The stronger the magnet, the better. And the magnet that I've chosen is really great because written right on it, you can see that this bar magnet has it noted which end of the magnet is the North Pole and which end of the magnet is the South Pole. So I have my other experiments, or my other parts, set up just over off to the side, and we'll switch our camera over after we complete the first step. Now I'm going to take my needle and I'll hold on to it very, very tightly, making sure that I'm not putting the pointy end anywhere near my fingers. Then I'm going to take the north end of my magnet. And if you don't know which end is the north end of your magnet because it's not written on there, that's okay. We can figure that step out together once we construct our compass. But you're going to take the north end of your magnet and you are just going to scrape or rub the north end on your needle in the same direction about 50 times. Sounds like a lot, but you could do this very, very quickly. Again, just remembering to keep your fingers away from the edge and that you are always scraping in the same direction. So you can see that I'm setting it down in the center of my needle and then pushing off to the side. And you just want to do this enough times that we're actually rubbing off a small amount of the magnetism. We're actually transferring the magnetism from the bar magnet to the sewing needle. So we're actually giving the needle its own magnetic properties. The more times you do it, the better. So you might notice I may have done this more than 50 times now, but that's only going to make my experiment work better. All right, that should be good. I'm going to set my magnet down. Remember that I swiped the north end on my magnet here. And I'm just going to go ahead and now I'm going to switch my camera back over. You can see that I have my bowl of water just sitting here on top of my paper. Now what I'm going to do is I'm going to gently set my plastic cap down onto the surface of the water. and it's probably going to move. But you want it to try to stay as still as possible or as centered in your bowl as possible. And then you're going to very gently and very carefully set your needle, which has been magnetized using the bar magnet, down onto the floating cap. Now you'll notice that the magnet is starting to spin, or our magnetized needle is starting to spin. And if you notice it gets stuck on the edge, you can always help it by bumping it away. Again, we're not trying to turn it, but if you just need to get it away from the edge there, you can. But you'll notice it's, no matter where it goes now, it's trying to find its way back to a very, very interesting orientation. Now I have out my phone compass here, and I'm just going to go ahead and set this down here on the screen. That looks like it might need to just be calibrated really, really quickly. Get my compass all set up. Give it a moment to calibrate. You can see that it's, something's loading down there. Ooh, there's you guys all on Facebook. Might be trying to do too many things at once here. Ooh. All right, this is a fun and interesting fact because I worried about this earlier. I wondered, oh my goodness, I dropped my needle down inside the water. Is that going to ruin anything? But what you might know is that magnets still work underwater. That dropping it down inside the water is not going to demagnetize your needle. So you can always just pick it up. I dropped mine a couple times earlier. And if you're worried about it, you can always take your needle and you can just try to remagnetize it again very, very quickly by, again, making sure you're using the north end, always swiping in the same direction, and then you can just set your experiment back up. So I'm going to set this back down, try to get my compass calibrated here, try to make sure everything is sitting very still so it doesn't fall, it's going to fall back in the water. There it goes. All right, give it a moment to point itself in the right direction. And let's take a look back at our compass. Now you can see where my compass is working when I hold it up, and then as soon as I set it down near our contraption here, it decides to change. Give it just a slight bump away from the edge here. Let's see if our magnet will actually right itself. You can see that it always turns, and it's aligning itself back with north on our magnet. Now, what's interesting is you might remember that the part of the magnet that or the part of the needle that I was magnetizing was actually the pointy end. And if we compare my compass here on my phone to the magnetized end of our needle, which is over here, they're actually pointing in opposite directions. And that's for a good reason, right? Because if I use the north end of our magnet in order to magnetize the needle, that means that that north magnet is going to be attracted to the Earth's south pole. In electricity and magnetism, we always say that opposites attract and like charges will repel. So the north part of our magnet, the pointy side over here, is actually being attracted to the Earth's north or south pole. And so this end of our magnet is actually the side that's facing towards magnetic north. And so if I were to make a note, I would say that this side is north and this side is south. So that is how you can set up your own compass at home using just a couple materials. Now let's take a look back at our slides for just a moment and talk about that movement. Now, like we said, the magnetic North Pole is not the same thing as the geographic North Pole. They are not in the same place, and they're going to get further and further apart because that magnetic North Pole is moving. Way, way, way long time ago, when we first studied the magnetic North Pole, first used it to identify the most northernmost part of the Earth in terms of its magnetism, that was actually located up here in northern Canada. And so if we got to choose, the magnetic North Pole used to be located geographically inside Canada. Canada truly did own it. However, as time has gone by, the North Pole is actually moving farther and farther and farther away from Canada and actually towards Siberia. And this actually happens at a pretty fast rate. The North Pole is actually moving about 130 feet every single day. Since we last checked, it's moved all the way from this point way down here, all the way up across the Earth's geographic North Pole, but it's continuing to move towards Siberia. Now, this is happening because of the centermost layers of the Earth. Now, the Earth has what we call a solid inner core. So the very, very center layer of the Earth is solid, and then the inner core just outside it is actually a liquid layer of iron. Now, there's a big temperature difference between these two layers. And so that means that those two layers are constantly moving and shifting. And since those layers are made of iron, the same stuff as our magnets, it is actually shifting and constantly moving the Earth's magnetic pole. So we think that over time, by the year about 2050, so in about 30 years, the magnetic North Pole is actually going to reach Russia. And so at that point, they will own the magnetic North Pole, but still no one will own the geographic North Pole because, again, that is made out of ice. All right, we are just about out of time for our episode today. If you have any questions about the North Pole, I'll do my best to answer them. If you have any questions about our compass experiment and how to set your own up at home, I'd be happy to answer those as well. A couple great suggestions about poking the needle through the cap. If you're going to try that, again, make sure an adult does that for you. I'm not even going to attempt that because I'm pretty sure it would be very difficult and I'd probably poke myself in the finger. So I'm not going to poke the needle through the cap. If you use a wine cork, just a small piece of it, it would be much easier to poke it all the way through both sides. But balancing it on top works really, really well. It's actually still arranged exactly how I left it. Even though I bumped the table a few times, it's constantly going to find its way back to pointing north and south. So even if I pick it up, move it, let's try changing my orientation here. Remember, dropping it in the water is not going to ruin your magnetism. If we give it a moment, it's always going to right itself. You can see that our north part of our magnet is constantly going to move back over here. The movement of the table might jumble it, but it's always going to find its way back to its magnetic north and south as it moves across the water. So it's just important that your cup is large enough that it allows your needle to fully rotate, kind of move freely without dragging along the sides. The more you can center it, the better. And the less you bump the table, which is I'm not doing a great job of right now, the less you bump the table, the better your magnet is going to work. Good suggestions over there. Ooh, someone made a great suggestion, though, that we could manipulate this, right? So this magnet is fairly weak. And right now, it's just being attracted to the nearest and greatest, most magnetic object, which is the Earth right now. But someone made a great suggestion that I could take one of my magnets here, one of these strong bar magnets, and I can actually manipulate our magnet here. So you can see that I can actually probably turn it a little bit, especially if I leave it down there on the bottom. And again, this is me using the north side of the magnet, which is attracted to the south part of our magnetized needle, because opposites always attract. North always attracts south, and south always attracts north. Just like when we talk about electricity, our positives and negatives are always attracted. Positives like negatives and negatives like positives. Opposites always attract. So if we take our needle here, our nearest, strongest, most magnetic object is always going to attract our needle until it falls right off. Great suggestion. Definitely try making one of these at home. I'm sure you can probably rig something up that works a little bit more stable than mine can. I'm doing a lot of moving around and my table is pretty shaky, but great suggestions, everyone. So if you have any other questions, definitely feel free to ask. We've got just a moment or two left. Of course, as always, thank you to Ford and Denso for sponsoring Echo Live. They are continuing to bring you these programs through the end of the year, even here from my home. And our last episode of this year, our last episode of 2020 is already here. It's going to be next week, Wednesday at 2:30 Eastern, just like all of our Echo episodes. And we will be doing a STEM year in review. So we'll talk about some awesome achievements and experiments that happened in this year. I'll be showing you how to do some experiments of your own at home so that you can be part of this year in scientific achievement. And if you're looking for any guides on how you can do science at home over this holiday break, visit the Michigan Science Center's website, written right down there at the bottom, mi-sci.org/at-home-science. If you want to show your family some of the fun stuff you've learned on Echo Live this year, that would be a great place to find some activity guides. Or, of course, you can always look back through past Echo episodes and try some of these things yourself as well. All right. Oh, thank you, everyone. Bye, Evan from Texas. Thanks so much for tuning in. It's been so good to see everyone. Thanks for taking out some time from your day today. I know that we're all on a holiday break, but I'm so glad to have seen you all here, and we will be back here next week. So one more episode for 2020, next Wednesday at 2:30. I hope until then you all have a safe and healthy holiday. Spend that time at home. Stay safe, stay warm, have some fun, and I will see you back here next week. And I wish you all the best luck in your year of school ahead. So bye, everyone.